This video will be looking at Chapter 10, Triangle Trigonometry, and is a continuation of looking at oblique triangles and how to solve oblique triangles. So, the last video we looked at case 2, where the problem, when they gave you a problem that the given angle was an obtuse angle, and this is that it was a case 2 problem, and so make sure that it's one that they're giving you two sides and an angle that is opposite one of the sides. So if the angle that they give to you is acute, then unlike the obtuse, where there's either going to be no solution or one solution, there's a possibility of two solutions, no solution, or one solution. So they call this the ambiguous case. If you want to find out more information on proofs for the laws of sines, you can go to this Khan Academy down here, and it's a great link to kind of get a better understanding of where all that's from, but it's beyond this course necessarily. You don't really need it. It's kind of like not needing to know how a gas engine works. You just need to know how to put gas in it. All right. So we do need to know how to solve the case 2 problem, so we're going to go through and break this down using the flowchart like we have been. And so we can see that we are given a problem, and it do have two sides and an angle. So we can see that that is going to be a case 2 problem. It's not a right triangle. And so it does have, we have a side and we have its opposite angle. And in this case, the opposite angle is acute. And so since it is acute, it's less than 90 degrees, then it can have one, two, or no solutions. So now that we know that, let's go ahead and see if we can solve this problem. So we know that using our flowchart that we're going to use the law of sines for this problem, and I think I am going to need to get the problem here. Just a second, let me bring this down here so we have these down here. There we go. And let's go ahead and start working on how to solve this problem. So we know we have sine A, and we have side A, and we have side B. So let's go ahead then and we'll go sine A, which is 30 degrees, and over side A, which is 4.62 feet, equals, well, we don't know sine B, and that's what we're looking for. And over side B, which is 9.24 feet. Okay, so now that we've got that, we can go ahead and figure this out. We'll multiply 9.24 by both sides. Okay. Clear that. So 24 times the sine of 30. And then we will divide equals and divide that by 4.62 feet. And so that tells us that sine B equals 1. Well, if sine B equals 1, we know what type of angle that is then, because if we go inverse sine, it tells us that it is a 90-degree angle. And so we know that B is a 90-degree angle. And I need to take a pause and open up the virtual office hours. Just a moment, please. Okay, back again, and that actually was a good reminder and shout out to everybody that on Thursdays from 6:30 to 7:30 there are virtual open office hours on Zoom. So make sure if you need any help, you tune in then. All right, so let's go ahead and finish working this problem. So one thing that we want to recognize is that let's go ahead and build this triangle. We have an angle that has a 90-degree angle in it, so that's angle B in this case. And we have another angle, and it's a 30-degree angle, and that's angle A. And so that must mean that if this is 30, 90, that this is a 30, 60, 90 triangle, and so this is one of our special triangles. And so we can remember then that if side A is 4.62 feet, so side A, opposite of angle A, is 4.62 feet, then that means that the longer leg is equal to side A times the square root of 3. So that would be 4.62 times the square root of 3, and it gives us that the hypotenuse is 9.24 feet. And so we can figure this number out if we want it in feet. And so 4.62 times the square root of 3 just a second, I think I need to. Okay. 4.62 times 3 square root, close parentheses signs, equals 8. And so that means that C, which is down here, so side C equals 8 feet. And so putting that together, we have our shorter leg 4.62 feet, our longer leg 8 feet, and our hypotenuse 9.24 feet. Looks good. If you don't remember from the last module that was the rule for a 30, 60, 90 triangle, and you don't have it written into your notes for the test, you might want to do that. But also you can just calculate that using the law of sines for C as well, and do it the longer way. So, not that it's that much longer. Okay, so let's move on to the next one. All right, so go ahead and pause the video and try to do this one yourself if you can. Okay, this one is just a little bit different than the last problem. And so let me go back again. So the last problem was an angle of 30. A was 4.62 and B was 9.54. And in this case, the only difference is B is, in the last problem, is 9.24. So let's see what changing it 3/10 does. And so we still need to go through. We recognize that this is not, at least we don't think it's a right triangle. We're going to not treat it as a right triangle because we haven't been given any reason to think it is. It's got an angle of 30. It has two sides and an angle, and then so we know that this is a case 2 option, and because the angle is an acute angle, we also know that it might have 1, 2, or no possible outcomes for a solution. So go ahead and we'll solve this and we'll see what we end up with. I'm going to grab this and bring this back down here. Okay, so we can get it all on one page. Okay, so let's go ahead then and solve this problem. So we are going to solve it using the law of sines, and we're going to go sine 30 over A, which in this case, A is 4.62 feet, equals the sine of B, and we, let's see, B is 9.54 feet. Okay, so multiply 9.54 times both sides, and I'll take a look at this. So 0.54 times the sine of 30 divided by 4.62 is 1.03 equals sine B, and hopefully that's sending red flags up to you, because anytime that you have a sine over 1, again 1 is 90 degrees, and then we see that this is not going to have an answer, because if we want to double check it and do inverse sine to be able to find the angle, it's going to tell us that that is an invalid input. So this is one of those case 2 problems where it does not have an answer, and so there is no solution. So this is basically what that triangle would look like. Remember, we just changed that by 3/10 of an inch on that one, and so in the problem, 3/10 of a foot. All right. So that concludes this video. We're going to have a second part of case 2 coming right up.